Welcome to the second episode of the DevOpsSpeakeasy podcast. And for the second episode, we have a great guest here, Rosemary Wang, developer advocate with Hashicorp. All time I say HashiConf instead of Hashicorp, so I need to be very careful.
It's okay.
With Hashicorp is with us here. Rosemary, welcome, and thank you for joining us.
Thank you for having me. It's pretty
And
nice to speak to people.
Yeah. Oh, yeah. My co-host, Kat Cosgrove, is here with me as well.
Hello, everybody.
And yeah, so as you already figured out, if you watched our first episode, we are live on JFrog YouTube account, and you can watch us there and talk to us there. Obviously also on Twitter at JFrog, at DevOpsSpeakeasy. So we try to make it as interactive as possible because, as Rosemary mentioned, we miss people.
We do. We do. It's lonely, y'all. We're all starved, especially developer advocates, because we're so used to like being around people all the time and talking to people and engaging as part of our jobs. Check on your extroverted friends. They're not okay.
Yes. All right, Rosemary, tell us a little bit about yourself.
Sure. So I've been with Hashicorp for the past year, except I was using Hashicorp tools before that. I had the illustrious role of being a DevOps engineer for a good amount of time. Right. But I still don't actually know what that means. Fun fact. So
First tackles are already up. He's mad.
I know. I don't actually remember really what the definition was at the time. I remember being very confused. I remember doing a lot of different things, wearing a lot of different hats. And then over time, I started doing more public cloud automation, public cloud work, applying infrastructure as code principles to delivering a lot of interesting things. And so I kind of traversed my way from DevOps engineer to a consultant and now to a developer advocate.
That's cool. So Hashicorp. I guess everybody know what they're about. It's like Terraform and Vault, and you know what, going back how old I am, Vagrant. What is this company about? What's their mission? What's the focus? What are we talking about?
Yeah, so a lot of the tools in the Hashi stack were really focused on data center automation and solving problems that developers or engineers had with data centers in particular. So when it started with Vagrant, it was like, oh, well, development machines weren't consistent. They weren't easy to come by. For me personally, when I was working on testing network switches, for example, I would use Vagrant to spin up a virtual switch and run tests on it, which was a lot easier than finding an appliance somewhere, wherever anybody could find a switch. And so Hashicorp has this tool set, first and foremost open source, but the second piece is focused on automating the data center and operating in a sense that gives people the ease of use and sort of lowers the barrier to entry to get started.
We in JFrog, we used Vagrant back in 2012.
Oh.
Yeah.
And, you don't know what the IoT team was doing then, because we were leaning on Vagrant pretty heavily when I was an engineer on the IoT team, because we didn't have Linux machines for our like actual development boxes, so we were using Vagrant for that.
That's really cool.
Great
and do you
tool.
still use it for IoT, or is it's not as frequent now?
I'm not an engineer on that team anymore. I'm a developer advocate here now, but if I was doing that kind of development again and I didn't have access to an actual like Linux desktop, then yeah, I would still just use Vagrant, I think.
I would say that Docker pretty much killed Vagrant, didn't it?
That's really funny, kinda. Yeah.
Kinda.
Right? Because that's the whole idea of Docker, right? You have your development machine, you just ship it to production, so you don't really need and now when Docker works with every operating system. It's kind of Vagrant is redundant, but I love how Hashi kind of reinvented itself and came up with another product, not less but even more popular. And I'm obviously talking about Terraform. What's Terraform niche, and how it managed to escape the fate of Vagrant, VMware, and everybody else who got disrupted by Docker?
That's a good question. I think that Terraform itself was built to extend to other providers and other different kinds of infrastructure. I think that Vagrant still has its place. A lot of people still use it, but it's for really specific things that they're looking for in the virtual machine space, right? With Terraform, the way that the project grew was that people wanted it to see it for Oracle. They wanted to see it for JFrog even. They wanted to see it maybe for even blogs or Google Translate. So people just really wanted to use the same patterns, which very simple pattern, plan and apply to a lot of different things. And it organically grew beyond the main cloud providers, beyond even a data center. It's pretty cool. I think someone from the Google team wrote a pizza provider, so you could order Domino's pizza using Terraform.
I love it. I love it.
Let's pause for a bit and go back and talk about what is Terraform for people who are maybe not very familiar with that. But what is it? Why? What is it for? What is it? Why would one use Terraform?
Yeah, it's a good question. If anybody's ever seen like the purple logo with the T with the blocks, that's the Terraform symbol. And basically, it's a way for you to declare what your infrastructure configuration should be, and then it's an engine that applies it. And it's more complicated than that, in that the logic itself under the hood is tested by a bunch of other people. So for, a really good example of this are the cloud providers. So, how many of us remember how to unlink an elastic IP address from a Kubernetes cluster from something else? I mean, that order of operations isn't that easy to remember. So Terraform has all of those dependencies mapped out. It has the ability to capture that logic and make the changes for you, so you don't have to think about that logic. So there's a lot of different pieces to it, but the primary interface is that you get to see the changes, you get to prevent whether or not those changes go to production, and then you can apply them, and it handles all that logic.
So that's infrastructure as code, as discrete. What is it? Declarative infrastructure.
Yeah, I mean, people have a lot of different opinions on this.
So let's hear it from the the biggest the single source of truth.
Yeah. No, it never. No. And that's the funniest part.
What do you mean? Even inside Hashi, you have different opinions on how to position tools like Terraform?
Well, I think positioning Terraform is pretty straightforward, right, in the problem that it's trying to solve. But in terms of the semantics, right, of calling it infrastructure as code versus infrastructure as configuration versus a lot of people actually, and not necessarily within Hashicorp, but even within the community who loves and uses Terraform, their argument is that maybe it's not fully infrastructure as code, because infrastructure as code should be one of the programming languages. Terraform uses a Hashicorp configuration language, and it's basically its own domain specific language. And the reason why it's like that is to help people who don't know how to code get started, right? To be comfortable automating and be comfortable with patterns. But there are a lot of people within the community that actually enjoy using a programming interface. They want to use Python, they want to use Java, they want to use C#. And in that regard, they consider maybe that as infrastructure as code and Terraform as infrastructure as configuration, while other people, a good number of people, claim Terraform is infrastructure as code. But differences of opinion.
I've never actually used Terraform, so this is useful information for me. I didn't know exactly what it did.
Okay, so let's try to map it. Let's try to map it for someone who never used it. Okay,
so I'm an engineer. I am the kind of engineer who will spend a load of time at the very beginning automating as much of my process as possible so that I don't have to touch this stuff later. I'm also primarily a Python engineer, and I really love Python. Like, I enjoy an opportunity to write Python. It's not a chore for me. So if this is something that I can write code to automate more of my infrastructure, that is the thing I would like to use. It's because I am lazy, but I'm lazy for tomorrow cat. Today cat is very driven to make sure that tomorrow cat can be lazy. Does this get me that?
Yeah, so it partly gets you that. You'll still have to write Python code to
Great.
translate it to JSON, for example.
Love to do that.
Yeah, exactly. So you can use Python templating, Jinja templating to still accomplish Terraform configuration, and Terraform then handles all the plans and applies. So from like an interface standpoint, maybe your interface changes. You can still use a programming language to render it out. But from the logic, the deeper logic underneath it, basically, I think I always come back to this idea of Kubernetes because I've been doing it a lot lately. But when you automate a cluster, when you automate the cluster, maybe you have a lot of things that you need for it. So networking, you need the cluster itself, you maybe need DNS. And so you can still declare with Python to render out to that configuration, I need a cluster, I need DNS, and I need network. And Terraform will be able to say, oh, network is first, then I'll create the cluster, and then I'll create DNS and maybe link that for you. So it will handle some of those order of operations. So today cat can be pretty, today cat, expends some extra energy figuring out how to template it out to JSON, but tomorrow cat can just run that Python script over and over and over and declare that, tomorrow cat wants a Kubernetes cluster with a network and a DNS, and they get that ad infinitum.
Tomorrow cat will appreciate that because she doesn't like having to remember which order those things go in.
No, I don't even remember them, and I hate to sit there and I like linking everything up. And then I remember before Terraform, I was playing with AWS when I was first learning AWS Cloud. I was creating VMs to host Cloud Foundry, et cetera. There were a lot of tools involved. And I remember getting the cloud bill back and it was like $200. And I was like, but I thought I deleted everything. I didn't.
You did not. You did not. No, I've done that before too. It was like some side project that I spun up with like CodeStar or something. And I thought I had torn it down, but like I left Beanstalk up or something. And it wasn't $200, but it was like $80. And it's not a good fee. I think everybody does that at least once, right?
Yeah.
Everybody's left some shit running on AWS.
Yeah, I think at least Amazon are quite forgiving for this type of mistakes, and you can write to their support and say, hey, look, I left it on by mistake. You've seen I didn't touch it, and then they just, I think, forgive the.
Yeah, they do.
Yeah. So that's kind of a tip that if you did that, just don't go ahead and pay it, but try to reason with Amazon support. You might get some of it slashed. But it's not a good way of operating, forgetting stuff and then begging the provider to forgive you. So and another thing is that actually, because those templates are unified, you can get, or universal, you can get the same behavior on different providers of the infrastructure using the same Terraform templates.
And that's where the question actually comes in the most, right? Everybody's like, oh, so that means Terraform gives me a common data model across multiple cloud providers. The answer is no. The answer is sorry, no. And it's a couple of reasons, right? Under the hood, if we actually look at all of the internals, what happens is that per cloud provider, it's different code. What it's doing is referencing the cloud provider's API. usually.
Mm-hmm.
And when the API does not have a common data model with the other APIs, it's really hard to basically create something that's giving a common model, right? So just because you say a load balancer in AWS doesn't mean that it means it's a load balancer equivalent in Azure. You have to write the similar configuration for Azure with Azure parameters and Azure requirements. But the reason why people enjoy it is that they can at the very least, have a similar common syntax or language or approach to how they configure the resources, right? So you can say, here's an Azure load balancer, here's an AWS load balancer, and you can create them side by side.
Okay, well, it's still pretty low effort.
Yeah.
Well, yes, but I wonder if there is no like minimal common level of denominator for all of them in the end of the day, especially when we are talking about more or less standardized things like Kubernetes, which is pretty much the same for every cloud. Is there any way for me to benefit from Terraform when I try to create my multi-cloud strategy?
Yeah, I think that the best way to express the benefits, with Terraform applied to multi-cloud in particular, is that, all of them have at least consistency in documentation. All of them have consistency in the actual domain-specific language. So if you understand that the parameters for an AWS load balancer are specific to AWS, you're able to sort of glance at the Azure Terraform documentation and maybe say, these are the rough equivalents in Azure. And for those who might be doing Kubernetes, it's even actually easier. What's really cool is that, maybe you create a Kubernetes cluster in Google, and then you create a Kubernetes cluster on, Azure, for example.
Exactly.
As long as you are able to create both of them, maybe they have different specifications, different versions, different node pool configurations. At the end of the day, to deploy the application, you can still pull those same outputs, right? So you'll still always get a Kubernetes cluster certificate. You'll still always get a Kubernetes, host endpoint. You'll still get a Kubernetes master authentication configuration somewhat, whether or not you've configured usernames or passwords. So you still have that Kubernetes as a contract is still kind of there, which makes it easier.
That sounds really neat. I'm gonna mess with that after this podcast because that sounds really fun. Sounds I really like getting into the weeds on configuration stuff like that. It's fun for me, especially if you have good documentation. Do you have good documentation?
Yeah, I'm actually pretty happy. Yeah, I'm surprised. The documentation for Terraform is really well maintained, which I'm very surprised about at times because it could be a lot of providers. It's like 200 of them. So outside of like AWS, Google, and Azure, there are a lot of other providers and they all have their resources documented. It's pretty cool.
Interesting. And there, what I wanted to talk about is a little bit about relationship between JFrog and Terraform. And that's interesting because we have a lot of points to of interaction. First of all, is like, for example, JFrog Artifactory one of the resources that can be configured with Terraform?
I have to actually look that up because unless you, I think that might be a leading question, in which case it might be yes.
Yes. It was a leading question and the answer is yes. All right.
Yeah, exactly.
All right.
And you can't have all of them memorized.
Yeah. Well, but at least the important ones, JFrog Artifactory. Come on, Kat. So, okay. What other type of infrastructure can we automate using Terraform? Setting up using Terraform. What else is kind of people usually do? So we spoke about obviously Kubernetes cluster. What else? What else is kind of used?
So Yeah, there are a number of observability tools that allow you to configure them with Terraform, for example. So New Relic, Datadog, repository, various version control systems. So GitHub, GitLab. There are also some other ones like even 1Password. A community member actually developed a 1Password provider, so you can configure your own 1Password with Terraform. And there are also the providers for each and every one of the Hashicorp tools, including Console and Vault. That I've developed a provider for blogs, for example, for like publishing blogs to Medium. Currently, yeah, it's interesting, and it's a way to just sort of have immutable blogs. I write them in Markdown, and then I have Terraform plan and apply, and it applies it to Medium as a draft, for example. You can also do it with Google Translate, which I also wrote just as a example. So yeah, there are a lot of different ways that you could use Terraform even outside of infrastructure configuration.
Interesting, very cool. And those pieces of configuration, what artifacts they end up in? I mean, how do I share those? So you wrote something for posting blog posts on Medium. I want to use it. How do we reuse?
Yeah. So every provider, so there's a plugin SDK, and the SDK helps facilitate development of providers. And providers are what are really valuable in Terraform. If you just use Terraform by itself without downloading any of the plugins like AWS, Google, Kubernetes, JFrog even, it's really not that much. There's not much you can do with it. I hate to say it, but there's not that much you can do with just the engine itself. So the reason why it leads up to this is that Terraform core, when you go to Hashicorp and you download Terraform, that's a gRPC client. When you install that, it's ready to consume protocols from a gRPC server, and the plugins are the gRPC server. So they themselves are actually binaries. They're artifacts that you can put on, an artifact repository, or even in JFrog. You can put them in Git, you can put them anywhere you want to. The idea is that you can distribute them and you reuse them. All that logic is bundled into this binary.
Yeah, and so when we're talking about sharing those, this is what is called like a Terraform module, and it's served from Terraform registry. Do I use the terminology correctly?
Yeah, that's just where this is confusing. There are a couple of components in Terraform that go into a registry. And so there's two things that you can actually host, two subsets of things. The first thing is a provider. So a provider is that binary. It contains the logic for orchestration against some API somewhere, a target API. Then there's the modules themselves, which you brought up. Modules are actually bundles of Terraform configuration. So let's say, I wanted to create a GitHub organization and I want a standard template for how to do it every time. So I take that, I put it into a bundle, which is a module, and I can distribute that to someone else to create new Terraform configurations and create their own GitHub organizations based on the subset of Terraform files. So providers are, let's say, Golang compiled binaries, while the modules themselves are Terraform configuration files.
So, okay, so, and providers are just shared like by using like a normal, any mean of sharing, HTTP server, JFrog Artifactory generic repository, or just place that you can get them from, while modules have a requirement for an API and registry and all this stuff.
Yep, exactly.
Yeah, I got confused by that, but
no, it is very confusing because actually I think it's all one registry now. What they call it under a registry now. So provider registry and module registry are all funneled into one general registry. Everything there.
And from what I know, Terraform registry implementation is on our roadmap as well. So I hope soon Artifactory will be able to serve as Terraform registry as well, serving modules, because providers can be just shared now for a
Yeah.
generic repository.
Yeah,
There is
but
nothing
I think it
specific.
is important though, right? JFrog is, when I used it, it was for, let's say, managed RPMs, right? So one of the big pieces was like, if you're in an environment highly regulated, air gapped, you're only allowing secure packages that have been pre-scanned and hosted in hosted and vetted, right? You would put it somewhere and you would make sure that no one is using the publicly available binaries or RPMs. It's the same concept with Terraform providers, for example. You may not want to use the publicly available latest bleeding edge version of a provider. You might want to scan it first.
Right. Absolutely. That's the reason why we do what we do, and that's the reason why JFrog Artifactory exists, among others. So yeah, absolutely. Having all your dependencies in one place, one centralized repository that you control is highly important. And I know that a lot of people are waiting for us to implement the Terraform registry APIs. And I hope that will be done soon, and we will be able to add this to the list of whatever 20, 30 package types that we have.
28 now, 28, right?
I think everybody counted differently, because what you need to do in order to know exactly is to do a joint set between those which is available as local repositories, remote repositories, and virtual repositories, because they are not all the same.
Right,
So,
and then generic count.
but it's a lot.
Generic? I would count generic, I think. The generic repo type. Do we count that as one of the...
Yeah, of course we count it. Obviously we count it, yeah. Right.
So there's disagreement at JFrog about how many artifact repository types we support, and Hashicorp can't agree on whether Terraform is infrastructure as code or not.
No.
Okay. So let's switch gears to other stuff that Hashi does, which is not necessarily Terraform. I think Terraform is the most popular tool at the moment. So this is kind of, we started with that. But I think that the second big, huge highlight for Hashi is the Vault.
Yeah.
Correct me if I'm wrong.
That's correct.
And that's because it solves a very, very common and very powerful problem of storing secrets.
Yes, it does.
This is all yours. This is all security. This is what you're passionate about. Let's talk about the hard coding passwords and committing them to Git.
No, we're not going to talk about doing that because that's a sin. So we might have a bunch of people watching this who don't know what the Vault is. So you want to give us a high-level overview of the Vault and why people should be using it?
Yeah, I'm happy to talk about Vault. So Hashicorp Vault is a secrets manager. It's a secrets manager. But part of that comes down to storing it. Part of it comes down to managing those secrets. And the other bit of that is another piece, which is rotation. It's very easy to issue an API token and forget that you issued it 30 days ago.
Absolutely.
You have to, it's really easy to forget that. And so what Vault will basically do is handle the revocation and the leasing, right, of that API token or that secret for however period of time you decide it's a time to live. So you can say, keep it for 30 days. If it hasn't been touched, then revoke it. So it's got a lot of interesting automation underneath, its core engine, but at the very end of the day, it's a nice way to store your secrets and rotate them really dynamically.
Oh, I want to ask so many questions. So before we get to the question that I really want to discuss, and that's, here are a bunch of ideas for storing password that might look good, but actually awful. We'll get to that in a second. I wanted to ask, how do I use it? Is it like a cloud service? Is it one of the services that I deploy on prem? What is the API? How do I interact with Vault? Because it sounds to me that there are so many variations of how do I need to consume my secrets that it's hard to come with a third-party off-the-shelf tool that can answer all those requirements?
Yeah. So Vault, you deploy yourself right now. You will take the open source binary online and you will set up a cluster wherever you desire to set up a cluster. It could be on-prem, it could be on the cloud, but you would manage it and for the most part, monitor it yourself. The way that you interface with it can be through three ways. You can do it through UI, but if we're really automating everything, you would maybe do it through API, which is also very, very much available. And there's also a CLI. So there's a combination of the three that organizations will tend to use. They usually tend to do a ton of automation with the API. And there's also kind of kits out there between Hashicorp and the community to help you expedite the deployment and the management of a Vault cluster as well.
We, for one, JFrog, we use Vault in one of our products in JFrog pipelines for exactly that, for storing secrets for all the CI and CD needs, because you need secrets for everything that you interact with. But why it's even an issue? I mean, we probably can do, like, I remember using CI servers previously when I just took the username and the password and then put them in environment variables and use those environment variables in the run of my CI. What's wrong with that?
Yeah, I defer to Kat on some of the security, some of the security vectors that would be in a pipeline. But part of that, at least what I see, is that ephemerality is a very good defense against an attack. So if the time to live for a secret is very limited, then you sometimes, for the most part, kind of eliminate the blast radius a bit. And so in pipelines, it's easy to maybe inject the username and password, but that still is fairly static in some regards. So unless you're doing automation within the pipeline to revoke that username and password after you're using it, or you have additional automation before that you've written to say it will only live for the lifetime of that pipeline, someone can still take the username and password and just run with it and do something with it. In the case of Vault, you can say maybe the database credentials are only available for the lifetime of a Kubernetes pod, for example.
Yeah, that's reducing the amount of time that a secret, a key, or whatever exists is it's an important part of like reducing the attack surface of something, and like using environment variables or whatever it's fine realistically, but it is something that could potentially be taken advantage of at some point, and you don't really want that information hanging out in like through pipelines indefinitely when you have the option to revoke it quickly, like with Vault, because like why give the risk? I don't think we should ever say that anything is unhackable or anything is ever like invulnerable to being taken advantage of, even though like environment variables do feel very safe because it feels like saying, somebody please try. So go ahead and take the precaution of building it in a way that it's automatically revoked after like X amount of time or whatever. That's just basic. Reduce the attack surface.
I have a question of that, but before just mentioning the environment's variable stuff, I think one of the most dangerous consequences of having environment passwords in environment variables is that today, when almost everything is spun up in containers, the environment variables is actually a file in one of the layers of the container, and unencrypted, and you could just see it there.
Yeah. It's a massive glaring security hole because you got to set it eventually.
Yeah, that's the main reasons why you shouldn't use environment variables, especially for third-party services, when the chances are that everything is containerized and what you actually think you're running as a script or as your Linux operating system is actually run in the container, and all your environment variables are actually an unencrypted text file. Yeah. So yeah, big no on that. I did want to ask about the rotation of credentials. Because from what I understand, it requires the service that you log into also rotate the credentials and accept the credentials that Vault rotates for you. So how does it work? Is this so again, for example, you need to log in to JFrog Artifactory to download your dependencies or to upload your artifacts. If Vault gives you a new password every 2 days, Artifactory needs to be aware that passwords are changed every 2 days. How that works?
Yeah, so that's actually really a great parallel to Terraform providers. Just as Terraform providers actually handle the logic of creating something upstream in a public cloud, for example, right? It handles the API calls, it handles the order of operations. There are actually Vault plugins, and the Vault plugins themselves contain similar automation to handle the rotation and the issuance of new keys. So to a certain degree, you do have to give Vault access to, wherever it is, to JFrog, for example, to make those calls on your behalf. But the idea is that it's locked in Vault, which is Vault itself, rather than something that's issued downstream, or something that's issued downstream that's using it. So you can install a series of plugins that will actually handle all of the automation. And if they're not there, you can also develop them yourself. A number of people have contributed their own plugins into the ecosystem.
I'm a big fan of anything that takes humans out of the equation where like security is concerned. Humans are really bad at repetitive tasks, as it turns out. We get distracted and lazy, and we might screw up and forget to revoke a password or a token or whatever. So I'm a huge fan of anything that takes people out of the equation on that. We're just not reliable enough for it.
Yeah, me too.
Let the robot take that.
Yeah, I even forget like which API tokens that I get issued somehow. Like I don't know, I don't remember them, and then I'll just end up reissuing myself them anyway, like because I just don't remember where I stored them or what it's being used for. So, and then all my pipelines break, but that's the way it works.
We do what we can.
Yeah.
Interesting. Okay, I think I got the idea. So in order for Vault to work with some third-party service to rotate the keys, it actually needs this plugin that knows which APIs to invoke on those third-party service to actually change the password. And once in a while, based on your configuration, it will do the API call, it will refresh the passwords or the keys, and then actually start serving them instead.
Yep, that is correct.
Nice. Cool. And actually, in terms of knowing those passwords and having all this as one centralized place, it obviously provides you the convenience and some kind of security, but it also exposes this place as a single, target of attack. If I hack into Vault, I know everything. How do we go about that?
Yeah, so the important part is access control in Vault. Vault in itself has a root token, which gives you access to everything. So don't have a root token. There's a big write-up of things you should do for Vault in production, and the big one, of course, is don't have a root token unless you really, really need it. And you can also rotate the root token as long as you have a set of keys, right? So there are a couple ways that it's mitigated within Vault, but the best practice is to make sure you have access control. Don't let some Vault user have access to every secret. If possible, give them access to the minimum number of secrets that they need, or even better, a one-to-one relationship with the secret. Especially if they're automation service accounts, most likely they'll maybe need like one or two sets of secrets. They're not going to need, the broad spectrum of them. And you can actually use some other policies to check whether or not they conform to the the sort of the source. So you can say, all right, I'll only allow someone access to this Postgres/DB username, but I won't let them have access to DB passwords, something like that. So those are the two simple ways in which it mitigates it. The other interesting one, which I personally like to mention, just because it's really fun, it's a fun analogy, is Vault, when you start it or when you restart it, in order to prevent people from basically breaking into Vault, right, you have to decrypt the store. And so in order to decrypt it, there's a set of keys that you get called unsealed keys. And they're a bit like the nuclear codes. You have to have like a certain number of them to unseal said vault and to get to the secrets. Yeah. So you distribute them amongst your teams. And then if vault goes down, for example, because someone's trying to hack into vault, or maybe your system isn't that highly available, something goes down, then vault seals itself, basically preventing anybody from extracting the secrets unless you have the combination of keys. So then you call someone, you're like, do you have the second key? And then they have to enter it. It's this whole thing.
It's the Spirit Stones from the Legend of Zelda Ocarina of Time. You need 3 of them to get the Master Sword. Like, yeah. That's tight, actually.
I know. I actually never heard the Zelda thing, but actually I might just use Zelda. I was using the nuclear codes, but like actually the Zelda analogy is even
totally
better.
The Spirit Stones from Ocarina of Time. Use that. Sorry for interrupting you, Baruch. I couldn't.
No. I just said that it's cool, and now it's even cooler. So yeah.
If I can find a way to cram some fantasy or video game reference in there, I'm gonna do it.
Okay, here you go. You just got it. Perfect. Okay, that makes sense, and I think we kind of cracked the mystery of Vault. Let's move to the next one by, I would say, my personal rating of popularity that you can confirm or not. The next one will be console.
I can't tell you if it's more or less popular, but we'll go to console because it's also pretty fun. I have a soft spot for console.
All right. So what is console? I think it used to be something, and now it's something completely different.
Yeah, it's a little confusing. I acknowledge it's a bit confusing. So console, I think, is more generally for service networking, and it's really interesting because it evolved over the years, right? It was, in some ways, it sort of was so powerful it could do a lot of things, and people were using a lot of interesting things for it. And so, but at its core, what it really solves the problem of is service networking in particular. So if, let's say, you need to discover services, console's really easy to put together to discover and register some of the services you have in your environment. It has a service mesh capability in there where you can actually control and manage layer 7 traffic if you want to, and more, more differently than that, not more differently, but the other bit of traffic management is denying and allowing traffic. So it also will allow you to deny and allow traffic between services if you've got it configured correctly. And kind of the side thing that it was, a lot of people use it for is a key value store. So there's, in itself, it's a key and a value store. So you can use it to back Vault if you want. Yeah, so you can use it. It will of course encrypt the data, but cool. You can actually use it as a backend for Vault to store that information. So if Vault goes down, it can pick up the information from console. The other thing that someone used it for was like health checking and monitoring, which some people do it at mass scale. Yeah.
Yeah, for sure. We had to like look for a solution for that when I was on the IoT team, because we were mocking up a situation where we were potentially dealing with like thousands of devices at a time, and we needed a way to like know which ones were alive. It's actually kind of a hard problem to solve.
Yeah.
So that's also pretty neat. Somebody did that with console. Huh.
Yeah. It's really interesting, and it was meant to be lightweight. So the reason why you might have heard it was one use case and then it sort of transformed over time was because, I mean, it's a really, really interesting tool that was built on like very interesting academic research. And so people they really enjoy its versatility, but a lot of people use it for service networking.
Yeah, so what I heard, my kind of personal journey around it is key value store, service discovery, and now service mesh. This is kind of the transformation that console were in my head at least. And the service mesh thing, we just did the podcast a couple of hours ago with Anton Weiss, who really thinks that service mesh is one of the most important concepts in today's world with microservices and Kubernetes, because it kind of allows you to manage the complexity of the microservices by sitting on this orchestrator of who speaks to whom and why. Is it really the biggest use case today, and how it's different from other service meshes like Istio, for example?
So I will say that service mesh is really fascinating as a solution to sort of the microservices problem, but interestingly to kind of edge devices in general. You know, our traditional network model doesn't fit right in either of those architectures. The era of like doing layer 3, layer 4 firewall configuration doesn't fit that space. It just changes too quickly. It changes, I mean, it's the registration of instances and where they are is just too much for a firewall or any traditional network device or even a virtual device to keep up with it. So in some ways, service mesh, I think it's a nice solution to the problem. The other bit of it that I think that, you know, Istio for the most part was really well applied in the Kubernetes space. But some of the other problems, the bigger problems, right, the things that may not be fully solved are outside of the Kubernetes space. And those are like the mainframes. Those might be edge devices that aren't Kubernetes, part of Kubernetes clusters. And so the neat part about Consul, which I personally like using it for, is putting it on these interesting devices that aren't really Kubernetes related, and allowing them to sort of join the conversation of the mesh, right? So if you have a mesh on Kubernetes, you actually can, with Consul, you can take some of the other ones that aren't going to be in Kubernetes and join the conversation a bit. So you get a single point of control across all of it. It's useful for like legacy migrations, for example. So if you expect to migrate very slowly from a data center to Kubernetes or to a new architecture, you know, it's neat to use a service mesh to be able to fine tune some of those parameters for you.
So it kind of takes the service mesh out of this Kubernetes niche and applies it to broader scope of devices. Another interesting use case that goes through my mind now is the edge computing, fog computing, IoT, call it whatever you like. How about those?
Yeah, so it's really funny because I want to see more of that. I want to see more of like the service mesh examples to talk about the problems in that space. You know, some people have used, you know, Consul and Nomad Consul, Hashicorp Consul, and its orchestrator Nomad to sort of address some of the problems in edge computing. What's really cool, and I'm really looking forward to it, is the potential to apply it. You know, Envoy, I think Envoy has like a mobile proxy now that's in development, and it'd be really interesting to see how this works on like mobile devices or some of the other interesting devices that are out there. But we have run Consul on Raspberry Pis before, and it runs just fine. It's a small binary, so.
Yeah, like speaking from experience, getting Kubernetes to run on edge devices can be really, really, really hard. So an opportunity for them to be like part of the devices, to be part of the network and not necessarily need to like force Kubernetes into it is, I think that's really valuable. We did manage to get Kubernetes to run on Raspberry Pis or on like embedded Linux devices, but we had to use K3s to do it. Like it is a real pain to get actual Kubernetes involved with the edge. They're just too low memory. So I think that's a viable use case for Consul, honestly.
Yeah, me too. And I hope to see, you know, more people exploring it, and we're definitely looking at it. We're just looking at some of the possibilities. But part of this is like even articulating the concept of a service mesh has been very difficult.
Yeah.
It's very abstract for, you know, to tell someone like, okay, a service mesh, what is it? How is it? What problem does it solve?
Oh, I think it took Anton like 15 minutes to explain it on our previous podcast. So like it's complicated. Like it's an abstraction layer that solves like an excessive complexity issue with a really, 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 really large network. But just because it's an abstraction doesn't necessarily mean it's simple. You know, it's still a bear. It just makes life way easier.
Hey, talking about edge devices and how standard meshes work or don't work with them, and do we really need to try and squeeze Kubernetes on them? There is another initiative which is an alternative to K3S, and that's the Linux Foundation Edge Foundation, Linux Foundation Edge Foundation, which tries to do what the Cloud Native Foundation did for Kubernetes and stuff for edge computing. One of their project is the Edge Virtualization Engine, the EVE project, and that's kind of the alternative. What they're trying to do is virtualization and not necessarily containerization of edge devices. One of the interesting startups in this area is Zededa, and Roman Shaposhnik, one of the co-founders, will be on this podcast sometime in the future, I guess in the next couple of weeks. And we will definitely ask him how they manage, what their vision of managing networking and communication in those fog computing clusters, and if actually console can be one of the solutions, and if they play with it, if they have any experience. And obviously we'll be more than happy to connect between you and maybe, you know, have another episode of all of us together talking about networking in fog computing and edge computing. That can be a very
to just have one guest on here. We can chuck a couple on and do a whole panel.
Yeah, so that's here just me thinking about what else can be interesting in this area. So yeah, okay. I guess again, if I need to summarize, simplify everything to one sentence, I would say that console is the way to take mesh concepts that help us battling complexity out of this Kubernetes niche and apply it to both edges, the very kind of legacy and the very futuristic edges of our computing world.
Yeah, I like that. I might borrow it.
You mentioned
you out left and right on things to say.
I know.
You mentioned Nomad. What is Nomad?
Nomad is a workload orchestrator. So it is, you know, beyond containers, right? You can use it for raw compute, and you can use it on a variety of different drivers. So it's not just like a Docker container. Someone I think built a Firecracker driver for it as well. So it has some extensibility beyond, you know, containers. And so you can use it for workloads that might not run well in containers. So this could be
wait a second. Workload orchestrator is what Kubernetes is, right?
Mm-hmm.
Okay. So here we have okay, it's like Kubernetes, but again, not only for containers.
Correct.
That's the thing. Okay. And what can I, how does it look like? What can I orchestrate? What people use it for?
So the common one that actually works out, a lot of people use Nomad for batching, like for batch jobs that they can't put in containers because the systems themselves are not, you know, they're not container amenable systems, if that makes sense. So they'll use it for some really heavy batch work where you have to scale up really quickly and then you have to scale down really quickly. You know, Nomad is built basically to scale very rapidly, and containers or no containers. So that's where at least a good number of people use it. A lot, and a lot of others use it for, you know, your web apps. They use it for, you know, some of the other stuff. For example, someone actually put it on one of our community. They're a great team. To the point, shout out to them. They created a keyboard wall. So they attached a keyboard, a colorful LED keyboard that they can control to Raspberry Pis, and the Raspberry Pis were part of a Nomad cluster, and they could control and make the keyboard wall dance, you know, with different, you know, choreography to the music, and light up and flash in different ways. There's a video on that somewhere on YouTube.
They build that for Logitech?
I don't know if they built it for Logitech. I know that the poor team like actually took apart, disassembled it, and then like drove it to Amsterdam last year for HashiConf EU, and then drove it back. Yeah, it was a big keyboard wall, but it was really awesome. And so, you know, you can pretty much put Nomad, similar principles to Consul, similar principles to most of the Hashicorp tools in that it's super lightweight. It's intended to be very lightweight as a binary, and then you can apply it to different operating systems, use it for different things to schedule jobs, however, whatever jobs you desire.
That's a really fun application of it.
Mm-hmm.
How does this scheduling look like? What is the kind of look and feel of this tool? How do I?
So it uses it's a similar configuration language to Terraform. So it all boils down to Hashicorp configuration language, which is that kind of domain specific language. But that's configuration language can be extended to other declarations beyond Terraform. So Hashicorp configuration language, the schema itself, right, generally looks similar to what you would expect with most container or even general or workload orchestrators. What's the name of the job? How many resources do you intend to allocate with it? You know, what's the underlying driver, if it's just a CPU allocation or if it's containers. So the schema in itself, you know, you declare it, you apply it to Nomad. There are also, you know, similar to Kubernetes annotations and other metadata. There's also, you know, kind of blue-green, you can do different manipulations of that, versioning, et cetera. So it is fairly similar in terms of the language of the capability.
How do I marry it with Kubernetes? I obviously have Kubernetes for my containers. I might want to use Nomad for other stuff. Is there like some kind of a simple integration, unification? Do I need to switch from one to another in some way, or I can somehow integrate between those two?
So the integration point actually is either you run one on the other or the other on the one. So it's a very like meta thing, but you can either run Kubernetes on Nomad or run Nomad on Kubernetes. And the reason why, yeah, it's a little confusing, but the reason why you might want to do one or the other is like maybe you have an application team or product team that is very Kubernetes focused. You can still have the operations and management of the Kubernetes cluster resources with Nomad, you know, and therefore you would run Kubernetes on Nomad, and then you would have other Nomad declarations for other jobs that are not related to Kubernetes. Or you can run Nomad on Kubernetes for, you know, for some other application. That one I haven't actually heard, but I have heard people run Kubernetes on Nomad.
It's like doable in theory, but you're not sure what the use case is there.
Yeah, I'm really not sure what the use case is. Although like Kelsey Hightower actually has HashiNetties, which is Hashicorp's tools on Kubernetes. So I think he actually has a Nomad on Kubernetes like tutorial and walkthrough.
We'll have to get him on here and see if he wants to explain like why.
Yeah, exactly. I think it's, you know, I think the idea is that maybe you want to be using native, you know, HashiCorp tooling. If you want native integrations with Consul, native integrations with Vault. Not to say Vault and Consul don't have integrations with Kubernetes, they do. But if you want to maybe have a similar approach and you want to have consistency across how you interface with the stack, Nomad and Consul and Vault have all the first-class integrations together. So there's a possibility of someone running Nomad on Kubernetes.
It's Kubernetes all the way down.
Yeah, exactly. Could just be.
It makes sense. Tell me, before we wrap up, and this is more related to our developer relations work, I guess, I don't know if HashiConf was planned and probably not going to happen now, at least in its physical form. What's going on with Hashi events? Where people now can go if they want to learn more, if they want to, you know, kind of talk to you guys. What's going on now?
Yeah, so we are going HashiConf digital. If you go to hashiconf.com/digital, It outlines that we've gone digital for the Australia and for EU conferences. We'll still be focused around contributors and community members from those regions who are amazing, and we should feature them. And it gives us a lot of great possibilities to actually interact with the community. I believe we're still going to have training days, so you'll still be able to have the opportunity to train on tools and understand what's going on, and hopefully we get some more participation. But both of them have gone digital. In this, you don't know what's going to happen. Hopefully Hashiconf US happens in October, but at this point, it's hard to say.
October. Yeah, no, we fingers crossed that by October everything will be back to normal again, or to what it was before.
Yeah. What about JFrog's conference?
So yeah, we're working on a
Working on an answer to
coronavirus appropriate response. Hopefully, we will announce soon what's going on with it, and whenever it will be, all our team and obviously Kat and I will be more than happy to collaborate with you, Rosemary, and doing fun stuff. In whatever format will it be. I hope this podcast is only the beginning of a wonderful friendship, and I hope we'll have an opportunity to do more, both in terms of this very podcast. As I mentioned, I already have a couple of ideas to invite you to more episodes, but also stuff like maybe webinar, because the stories of JFrog and Hashi are amazingly aligned. We kind of integrate in all the right points without stepping on each other's toes. So there is a lot of great potential for doing fun stuff together. And hopefully, when we are back on our conferences circle, I hope we will have the opportunity to do a couple of joint talks and providing more value with that as well.
Yeah. And if there's anything that the JFrog community wants to see in terms of specific content, etc., let me know. Happy to work on it, and we can maybe build something.
Yeah, let's just collaborate on some stuff.
Yeah,
I'm sure there's some dope demos we can build together.
Oh yeah. I mean, a lot of dope demos. My head is exploding of all the ideas that I have as a result of this conversation. With that, Rosemary, thank you very much for coming to the DevOpsSpeakeasy podcast.
Thank you for having me.
It's been a pleasure.
Yeah, now it's time for Twitter ads. This is why we're here. So where we go to follow you on Twitter?
You can follow me at, it's the first letter of the following phrase, Jack of all trades, master of none. And then there's a 08 at the end. So it's JOATMON08. And that's where you'll find me on Twitter and GitHub.
Cool.
We will have it written for everybody who are confused right now in the show notes. So no worry about that. That will be easy. Also, all the Twitter announcement that we did already contain, obviously, your Twitter handle. So it's very easy to find you and follow you on Twitter. Kat, it's your turn now. What is your smart Twitter handle?
My smart Twitter handle is Dixie and then the number 3 flatline, Dixie3 flatline. So far, only one person has noticed what that is from and actually said something about it. So if you know what that is a reference to, let me know, and you will get one socially distanced appropriate internet high five.
We can think about maybe a prize for figuring out what it is.
Also possibly give you a t-shirt and some stickers.
There you go.
We have new t-shirts coming out soon, and I can give you.
They're already out. We would be spraying them all over in the conferences, but no.
Social distancing.
From, and you'll get a t-shirt.
That's for sure. And my boring Twitter handle is @jbaruch, JBARUCH. So with that, thank you very much, Rosemary. Thank you very much, Kat. And
Thank you.
we'll see you in the next episode somewhere early next week. I
Monday.
think Monday. Yeah, Monday. We have Sasha Rosenbaum from GitHub coming up on Monday, which is pretty exciting and cool. So join that as well. And at JFrog, this is where, JFrog YouTube channel, this is where it's live. At DevOpsSpeakeasy, that's where it's tweeted. And we're working on uploading those podcasts to every possible podcast platform in the world. And this is coming as well. Thank you very much again, and bye-bye. Okay, stop recording. Yes.